In this video, we're going to look at building the Excel PV function. We're just going to do it on our own in a user-defined function. So we can make it a little bit different, improve it in one of the ways that annoys me a little bit, but you guys will see that as we get there. So real quick, let's just lay out the Excel PV function, and so we can talk about how we're going to kind of build it up step by step. So the first thing we got to look at is we need 5 variables: the interest rate, the number of periods you receive a periodic cash flow for, the future value that you receive at the end of those periods, and the cash flow timing, whether cash flows of that annuity occur at the beginning of the period or the end of the period. What I've done here is I've put that all into the Excel present value function. You guys are familiar with this by now. Essentially, we've put it in with the interest rate, the periods, the negative of that periodic cash flow, the negative of the future value, and that last optional argument of do the cash flow start at the beginning or the end of the period. All right, so now let's start out, and where you can see we're going to build kind of 6 different PV functions to eventually add in all the functionality to be able to do that exact same calculation as we see Excel doing. All right, so the first step, let's go back over to VBA. From our developer tab, I'm picking Visual Basic. Notice you probably don't have a module again, so we're going to go in, right-click into our file, insert a module. The first thing we do, option explicit. From there, we can start writing our function. So I'm going to call this function first PV function, and then we get our end function. I'm going to type in first PV function equals 1. So let's flip back to Excel again, just make sure that this basic formatting is working. So here we type first PV function. Let's just put the number 1 in there. Whoops, value error, right? It doesn't have any input arguments yet. So let's actually go over to VBA and fix that. So the first variable we're going to incorporate is the interest rate. So let's go in here and we're going to call the variable interest rate, and we'll make it a double. Right? Double because we want it to be able to be a decimal, right? That's the double precision variable type. We're going to use this for most of the numbers that we end up dealing with. All right, so now let's flip back over, see if that's working. All right, it works. We get $1 back. That's not the answer we're looking for yet, but that's okay so far. So now what we want to do is we have that interest rate in. Let's just do a little bit of a calculation. We're going to say calculate the present value of $1 in 1 year with interest rate provided by user. All right, so now to do that calculation, we just take 1, that cash flow in the future, divided by 1 plus R. The R is our interest rate. That's what we've called the variable. And we're going to raise that to the 1 because it's 1 period. So let's flip back over, check our function. We get 50 cents. That's because our discount rate was 1. So now if we want it to match what we were doing up in our Excel PV function, well, let's reference that cell argument. So here our interest rate is up in C2. We'll lock that reference, put that in, and now we're getting the same value that our Excel PV function is giving. Why? Because it's also using 1 period with $1 in the future. No periodic cash flows yet, and the cash flow timing doesn't matter yet because we're just talking about the future value argument. All right, so we've got that working. We got our first PV function, but it doesn't work really that well if we start changing some of these around, right? If we change to 2 periods, doesn't equal what Excel gives us. If we change to $2, doesn't equal what Excel gave to us. So now we need to take a few more variables in, and that's what we're going to do in our second PV function.